What did one fractal say to the other? I will be just like you. A fractal is a natural phenomenon that exhibits a repeating pattern that displays at every scale. Fractals are infinitely complex patterns that are self-similar across different scales, much like this fern that you can see here. Morphic resonance is a process whereby self-organizing systems inherit a memory from previous similar systems. In its most general formulation, morphic resonance means that the so-called laws of nature are more like habits. The hypothesis of morphic resonance also leads to a radically new interpretation of memory storage in the brain and of biological inheritance. Memory need not be stored in material traces inside brains, which are more like TV receivers than video recorders, tuning into influences from the past. And biological inheritance need not be coded in the genes or in epigenetic modifications of the genes. Much of it depends on morphic resonance from previous members of the species. Thus, each individual inherits a collective memory from past members of the species and also contributes to the collective memory, affecting other members of the species in the future. Now, this is a direct quote from Rupert Sheldrake's website at sheldrake.org, so check that out if you want to learn more about morphic resonance and the morphic field. I'm going to read an excerpt from a blog called Richard Hart Hates about a study done with monkeys because I think it speaks loudly to the morphic field and the definition I just finished reading. 5 monkeys are caged together and there are some bananas hanging from the top of the cage. Some scientists attach an automatic device for sensing if the bananas are moved. So once a monkey tries to get any, an electric shock travels through the cage so that all the monkeys get shocked. I know, this is a horrible experiment, but it makes a really incredible point, so just bear with me here. In the beginning, a single monkey climbs up to the bananas, touches them, and every monkey gets shocked. So he doesn't try that anymore. But the other 4 monkeys try the same thing, and the results come to be the same. Therefore, the monkeys learn something in common, which is, do not get the bananas, you'll get a painful electric shock. The scientists then replace one of the original monkeys with a new one. This new monkey sees the bananas and wants to get them right away, but the other 4 monkeys beat him up when they see its actions. Since these original 4 monkeys think the new monkey will make them get shocked, they stop the new monkey from getting bananas. This monkey tries a few times and the other ones beat him up every single time without ever getting to the bananas. Of course, all 5 monkeys don't get shocked. The scientists then replace another of the original monkeys with the new one. The second new monkey sees the bananas and wants to get them immediately and goes through the same process. The other ones beat him up. And the first monkey beats the newest one even harder than the others. That is just heartbreaking. Just like before, the newest monkey tries several times to get the bananas and is stopped by the others when they attack him. The scientists continue to replace all the original monkeys until no monkey actually felt the original shock remain. So all the monkeys in the cage right now are all new monkeys who have never been shocked. And yet, none of the 5 new monkeys dare to touch the bananas, and none of them know why. And they only know whoever wants to get the bananas will be beaten. So that's the excerpt from that blog. The question is, how did the newer monkeys know? They didn't read their Facebook or Twitter feed, right? French immunologist Jacques Benveniste published a paper in 1988 that caused great controversy. The paper, in essence, supported the concept of homeopathy. Very high dilutions on a certain chemical still showed traces of that original chemical. In fact, when no traces of that original chemical remained, the water still held the memory of that chemical or molecule. What he realized was that each molecule had its own signature frequency, and that it was the frequency that was getting stored and recorded. In fact, this is the main way cells communicate, through frequencies. We are constantly inundated with a ton of information. We typically can only process between 7 and 9 things plus or minus 2, and our brain is only responding to a very small number of frequencies. For example, we cannot hear a dog whistle because that sound vibration is between 23 and 54 kilohertz, far above what the human ear can hear. To human ears, a dog whistle makes a quiet hissing sound. Microwaves are a form of electromagnetic radiation with frequencies between 300 megahertz and 300 gigahertz. The human eye can only see within the visible spectrum, which you can see here on this graph. That's to say, colors that fall into the visible spectrum. So ultraviolet radiation has a much shorter wavelength than the visible violet, and that is why we can't see it. Based on the chart here, take a moment and notice what our brain is capable of perceiving. And more importantly, notice what is out there that we are not able to perceive. Measuring instruments have made it possible for us to know that there are other frequencies, even though our brains don't have the capacity to process at that level. I read somewhere that a snail, its nervous system, can only process things that happen within 3 seconds or longer. Otherwise, if, for example, if you had placed an apple in front of a snail and you just snatched it away really quickly, the snail would have the experience that the apple disappeared out of thin air. So, imagine that. Lynn McTaggart wrote a book called The Field, where she talked about the field being the 0-point field, and where she proposes that if the brain is sending and receiving frequencies all the time, then the field is where the memory is stored, whether it be individual or collective memories. Her entire book is backed by scientific research and a ton of studies. I think she does a fabulous job outlining how she got to her theory. There's also a 2-hour YouTube video of her talking about her research, which is quite fascinating. Our brain is a unique and fascinating tool, and so is our mind. Knowing that you are only able to perceive such a narrow bandwidth of data is an invitation to really open up to the unknown. Ultimately, this brings us right back to section 1, the beginning, and our assumptions and bias. As you move through your world, ask yourself, what am I not seeing in this moment? What am I choosing to only see in this moment? And watch yourself start to notice things you may not have even been aware of.